Welcome to the fourth video in this series of modifying a 3D mesh using C#. In our last video, we implemented the code to allow us to rotate around the camera around our scene. And in this video, we're going to implement the code that allows us to zoom in and out. Since last time, I did a little bit of research. If you remember last video, when I created the skeleton of this method using writer, and it created this base input and sent the event in, and I wasn't sure what to do with that. I mean, this is sending the event up the object hierarchy, and I wanted to verify that that's what that was. Also, to restate, I'm learning C# as I'm going along here. I am a Java developer, but C#, although there is some similarities, there's quite a bit different. So I think this is the same thing as calling in Java super dot and then the method name. So I wanted to look it up to make sure. And from what I can tell, that's exactly what this is doing. And I've also looked on the Godot website, and it doesn't seem like in any of these lifecycle methods for these nodes that they ever call the base method at all. So I don't think we need that code. So I'm going to go ahead and get rid of this code. And by this code, I just mean this line here, this base input method. And also, when I was looking this up, I saw this piece of code that basically gave the idea to hit the, tap the escape key and close up the window. And I think that might be nice to have. So I figured to kind of get warmed up before we get into the zooming stuff that we would implement this just very quickly. So let's go into our code and let's make a case in our keyboard area for keylist.es escape. So if if input event key dot is pressed, then I think we're just going to exit here. Get tree dot, was it just exit? No, what was it? Get tree dot quit. Okay. Let's do a break here. All right, so let's run this and let's see if the escape key quits here. This isn't really part of this video. I just figured it would be nice to, or this topic, I just figured it'd be nice to add the escape key since I saw it on the web page. All right, so Alt rotates around still, and then if we tap the escape key, it does close up the application. Fantastic. Okay, so let's go ahead and think about what we're going to do here for the zoom. And I think with the zoom, what we're probably going to want to do here is, remember we set up this camera helper and it was at the center of the world here, which was mostly in line with the cube. So we were rotating the camera. When we rotate the camera helper, it's rotating the camera mostly around the center of the cube. I mean, the camera helper is at 0, 0, 0, and the cube center, remember we had to lift it up in the first video to get it above this floor. So for rotating around, it didn't matter, but when we zoom in, we're actually going to be using this to zoom in towards, and we probably want to make sure this is exactly where we want it. So what we want to do, the easiest way to do that would be to check the cube out and see what its Y translation is. And I'm just going to go ahead and copy this. And then I'll go to the camera helper and I will move its translation to that same amount. I hope. There we go. All right. So now the spatial that we're using as the camera helper is at the same center as the cube. So when we zoom in, we're going to be zooming in on the spatial. So in our case, it's going to zoom us right in to the spatial. But then one thing we have to remember is when we were setting up this camera, we were just kind of aligning it with our eyes, like where we wanted it in the scene, and just by rotating it around in the scene editor here. And when we zoom in, we really want to make sure the camera's looking at, it's centered exactly on the thing we're going to be zooming in on. And luckily, and let's see if I can find this. I think it's under spatial. Luckily, the spatial object has a couple of LookAt methods. One's LookAt and one's that LookAt from position. And I think we just want the LookAt. And it takes the vector3 target and which direction is up. So I think that's what we want to use here. So then we have to think about, well, okay, how do we implement that in code? And that should be pretty easy. We don't need to set this every time. We just want to set it when the game first starts. So I think we can do that in the ready method. And much like we did the camera helper here, let's first let's grab the camera, because we're going to need to, when we zoom in, we're going to be moving. When we zoom in, we're going to be moving the camera like towards the camera helper. If you remember last time, I mentioned that when we were rotating the camera helper, you should think of it like a rope, that there's a rope on the spatial that's going out to the camera. Well, basically when we zoom in, we want to kind of reel in that rope or reel it out. So we're actually going to want to grab the camera as opposed to the camera helper here, because if we move the camera helper, I mean the camera, that's the whole point of childing the camera with the camera helper, is it's going to move it up and down, and that's not what we want. For rotation it was, but not when we're actually zooming in. So since we're going to be grabbing that and moving that every time we're through the input, we probably want to set this up so we only have to get the node once, like we did with the camera helper. So let's go ahead and create a private member variable, and we'll call it camera, and then we'll go down to the ready method and we'll get the camera. And we will get node. It is a camera. And the path for this is camera helper camera. Because remember, it's a child of the get node, since it's on the main node, it only looks at the children when you do a get node. So the script itself is on main. So when I get a node, if I just use the node name itself, I can only go for one of its children. And main only has 3 children right now: the meshes node, the lights node, and the camera helper. So what I need to do is address it by the camera helper, which is a child of main, and then slash, and then camera, because it is a child of camera helper. So that's what I did here. And then we want to use that LookAt, and let's go back to the web page. So it says the target, which would be the camera helper, and then we have to tell it which way is up. And luckily in our case, up is global up right now, so this will be pretty easy to set up. So what we'll do here is we'll say camera dot LookAt. We want where we're pointing to, so that would be the camera helper. Now we want to get its where its center point is in the world, and the way one would do that is one would get the get global transform. There is a get transform too, but the get transform gets the local transformations, and we actually want the global transformations because we want to move this in the world. So you get the global transform, and then you'd get the origin, which is the center point. And then we got to tell it which way is up. Well, up is 0x, 1y, 0x, or 0x, 1y, 0z. So when we run the game, the camera is going to probably move a little bit. It better move a little bit. That's the whole point of this code. So let's make sure that what the end game result is what we want, as far as where the camera is actually looking. So I'm building the solution. Okay, lifted it a little bit, maybe a little bit higher than I would like. So why don't we back this up just a little, and let's move this down just a little. Let's see what this looks like. Okay, this should be good, because again, remember, we're going to zoom in and zoom out, so a starting place for us to zoom in and out, this will be fine. So the next thing we have to do here is I want to determine how close I can get to the camera, how close the camera can get to the cube, and then of course how far away. I don't want the camera to be able to go inside the cube, and it definitely could if we keep zooming in, because the way we're zooming is we're actually going to be moving the camera. So this is how we're going to zoom. So we don't want to do that to go inside the cube. So we probably want to set up some distances here. So let's create some variables for that. So at the top here, let's set a constant float minimum distance. Put a capital D there. And we'll make that equal to, how about 3? I'm not sure if the convention here is to make variables with that underscore or not. I'm not going to do that, and we'll see if anybody complains. So then I'm also going to create a maximum distance. And we'll make this, let's say 20. So what these are going to say is that I can't get any closer than 3 Godot units close. And the farthest I can zoom out from that camera helper is going to be 20 Godot units. So then the next thing we want to do here is we want to capture the control event. And let's put the control event before the escape one we just added. CO control. Okay, so what do we want to do in here? Well, we probably want to have a variable similar to this is alt pressed, but we want to have it for is control pressed. So let's do a little cheating here. Copy paste is a friend. So we have this is control pressed. So what we want to do is, honestly, we're going to be pretty much re-implementing this for control. So let's just copy paste it and change what we need to. So is control pressed. If is control pressed, and the echo that we talked about before. Now the good news here is we're going to set this up so that you can't rotate and zoom at the same time. So the way things are set up, the way things are going to be set up, you either have to hit Alt and move the mouse or Control and move the mouse. You can't hold down Control and Alt and do anything. If you do that, it's going to default to one or the other. And in our case, it'll be the first one that's implemented here. We'll handle that in the mouse event to show how that's going to be handled. So because of that, we can use the same variable start dragging position, because we're only going to care about dragging when it's in one of those modes, not both of those modes. So then what we want to do now is we want to go down to the mouse area. And so what we're going to do here, it depends on when we would check for these, on which key, whether rotating with Alt or zooming with Control is going to take precedence if you tap them both at the same time. It really depends on who gets the if and who gets the else. Well, since Alt already is in an if, we're going to put this in an else. And we're going to check for if is Control pressed. Now we're going to always need this distance, so instead of doing it twice, why don't we just move it up here so we can compute it just once for either case. And then down in is Control pressed, what we're going to want to do is we're going to want to get a vector that is basically, we need to know what direction we're going toward. Let's go back to Godot. So we need to know, basically we want an arrow from the center point here to the center point there so that we know which way to move. And the way one would compute that is, I was doing some research, if I can find it. So Godot has this nice page where they talk about vector math, because I always get confused if it's A minus B or B minus A, and luckily they have a cheat, not there. Luckily they have a cheat tip. I guess it's not a cheat, but for me it is. So it says to find a vector pointing from A to B, use B to A. Well, in our case, A is the camera and B is that camera helper. So we would take the origin of the camera helper minus the origin of the camera. So let's go ahead and do that. So what we want to do here is we want to create a vector3 variable, and let's call it camera to spatial, and we want to make this the camera helper dot get global transform dot origin minus then the camera dot get global transform dot origin. So this is going to give us the vector that we need from the camera to the spatial, the camera helper. So we're going to need to know two things. We're going to need to know the length of this vector so that we know the distance. And so let's go ahead and compute that now. So camera to spatial length equals the camera to spatial vector, and luckily it has a, I guess it's just length. It has a length method. So we know the length because this is what we're going to use to check against these distances to see if we're actually supposed to do something. So we have the length in place. Now what we need to do, so this camera to spatial vector has a certain length to it, which we computed. But the way vectors work, you know, all we care about is the direction. We don't care about how long the vector is. We just care about what the direction is it's pointing to. And in fact, if we don't do anything with this camera to spatial vector and we leave it as is, its magnitude is going to be the increment that we move every time there's a distance change in the up and down of the mouse pointer. And we don't know what that's going to be, what the distance here is going to be. So what we want to do is we want to make this vector, camera to spatial, we want to make it in the same direction, but only make it a length of 1. And the way one does that is that's called normalizing a vector. So what we're going to do here is we're going to create another vector. We're going to call it camera to spatial normalized. And luckily, vector3s have a method to get that vector. So it's just as simple as that. So all this is going to return back, all this normalize is going to return back is this vector. It's going to be pointing in the same direction, but the vector itself is only going to be 1 in length. That way it'll be more consistent when we move our mouse up and down, how we zoom in. So we have everything we need here. So what we want to do now is we want to actually, let's go ahead and move the camera, but then we need to do some checking around that to make sure we're even supposed to move the camera. So let's try this. So the first thing we want to do is, how would one move the camera? Well, one would do a camera, and then one would do a global translate. And again, there's, I believe, yeah, there's also a translate method here, but I believe that is by local coordinate system, and we don't want that. We actually want to move it within the world. So we want to go ahead and do this by the global transform. And get global transform, get global, just global translate. Global translate, there we go. And it's going to take the distance that we want to move. Well, we computed the distance dragged here. And remember, up in the alt pressed, we cared about the x component of what was dragged, basically left and right. Well, in this one, we're going to care about the y. So let's go ahead and start there and say distance drag.y. Okay, well, much like we did here with this radian angle, if we try to move within the amount of pixels we're moving up and down, we're going to zoom in like uber fast. And I was playing around a little bit, and I think this value will suffice. And this one, I was thinking about using a constant for this number, but as you can see, this is a 0.05 and this is a 0.005, so I'm not going to go ahead and do that there. Okay, so this global translate actually takes a vector. So this tells this particular thing we just computed gives us a, whatever you're going to do it by this amount. The same way we did up here with the radians, we said take this and rotate it by y by this amount. Well, the do this was in the method itself called rotate y. Rotate y was to do this in this direction. Well, this one isn't a rotate y or translate y or anything like that. It's just saying global translate. So we're certainly telling it how much to do it, but we're not telling it in what direction. So what we want to do here is we want to give it that direction vector. So we want to put parentheses around this because this is going to be the value that we're going to multiply by this camera to spatial normalized. So this is doing something very similar to what this is doing. So this first thing is saying, okay, do this distance dragged y and times it by this value. So this will give you the amount of thing to do, 0.5, 0.25, quarter, half. But what do I actually do? And up here, the method itself told you I'm rotating y. Global translate, well, I can translate in any direction. Where am I going? So this one you kind of have to do the math on to get this to happen. So what you're doing basically is computing this value you're going to move it, and then you're doing a vector multiplication. You're doing this on a vector to multiply against the vector, which will go ahead and basically, since it's a unit vector, this will take that unit vector and it'll take those values and knock it down by that amount. And it'll be easier to see when we are actually in the viewport. And then, much like we did up here, well, we just translated it. So let's pretend that the dragging stuff has started over again because we just did it. So this would work, I believe. I mean, let's go ahead and check, but this would let us go way far away and way inside the cube. But let's, before we put the check on there, let's actually see if this works. We'll also verify that the Alt key still rotates us around. All right, so we're there. Alt still rotates us. So I'm going to hold down Control and pull down. and it's zooming us out and letting up on control, holding control, zooming out, letting go of control, holding control. See, I mean, now we're past the clipping plane, so that's why it seems to disappear. The camera has a max distance it can see. So we don't really, and the same thing would happen if we tried to go too close to the cube, like we'd be in the cube, and we don't want that. So this is almost what we want, but now we want to put those boundary checks in place, and that should be pretty easy to do. So what we're going to do here is we want to put an if around whether we globally translate or not. So what we want to, let's just get this in place. So what we want to do is we want to see if this camera to spatial length, which is the distance, we want to see if that's greater than the minimum distance. And the distance dragged dot y is greater than 0. In fact, let's put these in parentheses here so that we can guarantee order of evaluation. Let me close up that up. All right, so we want to make sure if y is 0, then that means we're not any closer. We're not any closer than that minimum distance. And then we also want to make sure we're not going to go farther than what we have for maximum value. So we'll do an OR on that. We'll do this. We want to make sure that the camera to spatial length is less than the maximum distance, and the distance dragged dot y is greater than 0, or less than 0, excuse me. And let's put that and close that up. All right. So basically these two checks here, we're basically saying if we're moving in a direction where we're trying to get closer, is our length still greater than minimum distance? Or if we're trying to get further away from the cube, which is this y direction, are we less than the maximum distance? It might have made sense to put the distance dragged y at the beginning here and then and that just for readability, but I think this isn't horrible readability. So this should prevent you from getting closer than 3 and further away than 20. I think 20 was our maximum. Yeah, so 3 or 20. So hopefully, in theory here, we have done everything that we need to do to get this to work as we want. So let's take a look. So let's hit the play button and build the solution. It's opening up the game window. All right, so Alt key moves around, awesome. Holding down the Control key and moving up. It's zooming in. I'm still holding down. Okay, I'm still holding down the Control key, but notice that I'm not getting any closer to the cube. So that's hitting that 3 mark. So I'll let go of Control, hold down Control again. Now I'm pulling down. I'm still holding Control down, still holding Control down. I'm still holding Control down, but I can't get any further away than 20. And I think this is going to be good for what we want because we can zoom in and rotate around, and we can actually look at this mesh enough to start making some modifications. And you'll also notice as we get closer, I mentioned this in the last video, remember how we created the wireframe mesh, and I think it was video 2, and basically we drew it around the cube and then we like scaled it up. Well, you can see, I think I said in the last video, it like had the baggy pants effect, and to me that's just, you can see that it doesn't quite fit the cube. It's like around the cube, but the scaling factor is probably still a little bit too much. And as in the next video, when we start modifying the mesh, we'll play with that number to try to get this so that this mesh is close enough to hugging the surface that it doesn't matter to us, because this view here is basically just for our convenience to see what's happening to the mesh. So I'm pretty happy that we have the rotate happening and we have the zoom happening. And I think for now that's going to end this video. And in our next video, I think we are now finally ready for the whole point of this series is to use the mesh data tool. Most likely we'll get the surface tool involved, and we'll start actually modifying this mesh. And what I mean by that is, maybe we'll click on this and it'll know that I've selected this face, and maybe we'll subdivide the face, or maybe we'll create another triangle. I mean, I haven't really decided yet what we're going to do here, but I want to be able to actually modify the mesh in some fashion. And that was the whole point of this series. It took us 4 videos to get the prerequisites done, but starting with the 5th video, we're actually going to be ready to start doing this. And this is the whole point of why I wanted to explore this, because I don't know how we're going to do this. I mean, I looked at the web pages, and I honestly have not done any of this yet on my own. So this will be the learning experience that I was looking for. And if I tap the escape key, awesome. That was an extra bonus implementation. So I think I'm going to stop the video here. And it may be a little bit longer for me to get the next video out, because I think that I'm going to have to do a bit more research. Everything we've done up to this point hasn't been all that hard. I mean, there's been some concepts there and a bit of time consuming, but like there's nothing really hard there as far as understanding vectors or drawing triangles or even rotating. But now we're going to be actually getting into meshes, and one needs to be careful about that, because you have to worry about the mesh's topology and making sure the topology doesn't get into a bad situation where you're having things intersecting things. That's why I don't know exactly what we're going to do as far as, maybe we're just going to add a point and then it will compute some new faces. I honestly haven't decided yet. That might be the easiest thing to do, is to put my mouse pointer over an edge and click on it. It'll put a point there and maybe recompute the faces of the 2 faces that are connected with that edge. Don't know if that's what I'm going to do. I'm going to have to research a little bit more to see, but that seems like an easy thing to do. If I got really ambitious, I might think about clicking on a face and then trying to like extrude it, but that's getting a little bit more complicated, and it seems like we should start this one step at a time. So I'm kind of feeling better about maybe we'll just put the mouse pointer over an edge and then click there, and it'll create a vertice there, and then just recompute the faces around those 2 things, because we're going to have to as far as I know, we're going to have to do quite a bit of that recomputation of faces ourselves, and that may not be super trivial to do that. I, again, haven't looked into it enough to know for sure if that's going to be the case or not, but that's the plan for the next video. So anyway, I will stop the video here, and that will be the plan for next time. And I am hoping to get a video up. I've been trying to do these once a week, so this one might be next weekend. We'll see. It might be 2 weeks before I'm ready to actually present that. And most likely it's going to be one of the longer videos on this topic on this playlist. And I've already got some long videos, so by me saying that means that might actually be a substantial length of video. I might think about cutting it in 2. There's just a lot of mights here. So anyway, I'll cut the video here, and thank you all for watching, and I will catch you next time.